So elements of a laser. There are 4 main parts of a laser. I mean, very, very simplified, theoretical, right? So what is a laser? A laser is an optical oscillator that emits an intense, highly collimated beam of coherent radiation. And it is basically made up of 1, what is called a pump, 2, a gain medium, 3, a resonator, or also called an optical cavity, and 3 laser systems that include power outputs and cooling systems. And I'm going to try to draw that picture. It'll have 2 mirrors on the outside that again are limited by how far we could have them by the number of modes we require. It will have a gain medium in the middle and a laser beam that will be emitted. And then it has power supply on the outside. Okay. That becomes a part of the pump. Okay. And this will be our laser beam. And this will be the gain medium. This will be mirror M1. This is mirror M2. Like this whole part is called the pump. So the battery, let me draw it on the side. The battery, the switch, and then the thingy all together is called a pump. You know, the wraparound coils. Okay, so now let's look at them briefly. So what is a pump? A pump is an external energy source. And what is it responsible for? For producing the population inversion in the gain medium. They could be optical, they could be electrical, they could be chemical, or they could be thermal pumps. What is the requirement? The only thing that they require is that they should cause, the pump should cause a population inversion in whatever gain medium you have. What was population inversion? We talked about it, right? It is the fact that atoms need to go into their, that's it. And more atoms need to be in their excited state. So the pump, what it's doing is it's causing that population inversion in the gain medium. Okay, so then next comes the gain medium itself. What is a gain medium? So most of the laser systems are known by the gain medium that they use. So for example, you will have a helium neon laser or an argon laser or a ruby laser. and they are named after the gain medium that it uses. And the gain medium determines what kind of a light you will get, whether it'll be green, red, whatever colored light you will get out of it. Okay? So, laser systems are generally named after the gain medium they use. And energy levels in the gain medium determine the wavelength or the color of the laser radiation. The difference between green, red, infrared, what kind of a laser are you using? So you can have basically any kind of a laser you want, all the way from ultraviolet to infrared and everything in between. So you could have wavelengths from ultraviolet all the way to infrared. And more than half of the known elements can be used for lasing. But the most common ones are 632.8 nanometers for visible radiation from neon and 10.6 micrometers for infrared radiation from carbon dioxide molecule. The most important requirement for a gain medium is its ability to support a population inversion. And remember, population inversion is not a stable situation, right? Things are inherently lazy. They do not want to be in their excited state. So we have to force them to be in their excited state. Thank you. Number 3. Number 3 was what? A resonator? So what is essential about standing? What was the essential part about standing waves? What did we need? Those are called resonators. Fancy word for the 2 mirrors that we use. Okay? So the important part for this is carefully aligned mirrors centered along the optical axis. They could be plane or they could be curved or some combination of plane and curved. They just have to be 2. They have to be very carefully placed such that their distance between them carries the number of modes we want. These are also called feedback devices, optical feedback devices. And what are the 2 important things? The shape and the distance between the mirrors determine how many modes can be present in your laser. Remember we did that here? Yeah? That's exactly where this comes in handy. So do we want to write this again? That the mode of the electromagnetic field within the laser cavity is determined by, number one, the shape of the mirror, and number two, the separation between mirrors, okay? And D equals m lambda over 2, and the frequency, and hence the wavelength, and hence the color of the laser will be given by the last one, number 4, is the cooling system. So this is not very important in the little lasers, I think, that you will take apart, but that is very essential for the lasers that Dr. Faust uses. And in order to understand why this is so important, okay, let me start here. The pump energy that does not become a laser output eventually becomes thermal energy, which is bad, right? If you have a lot of heat, what will it do? It will destroy your laser. So as an example, for a argon ion laser with a 10-watt output only, the overall efficiency is about 0.05%, which means my total power used for a 10-watt laser divided by its efficiency is 20,000 watts. Out of 20,000 watts, how much of it is being wasted? 99.95% of it is coming out as heat. So what if you don't care and you let that heat stay there? It's going to destroy your system, right? Very, very quickly. So in order to avoid that, we need to cool our system. And usually that is done by what is called a cooling jacket. So to cool it, we use what is called a cooling jacket. And what is a cooling jacket? It is water or some kind of an oil that absorbs that heat and takes it away. Or sometimes for less stressful situations, forced air is sufficient. Do you know what forced air is? Like the fans on your computer.